Hi everyone, this is a continuation of my series on how FPV video systems work. And today we're going to be talking about the HDZero or Sharkbyte digital system. If you haven't seen my previous videos on analog FPV and the DJI digital system, then it's worth watching those first because we're going to be relying on some of that information to explain this system. I'll put some links down in the video description for you. If you like this sort of content, hit that subscribe button, sit back and relax because we're going to get right into it. So before I get into the technical capabilities of the HDZero system, I want to take a moment to clear up some confusion about all the different names that there are out there for this system. So Divimath is the company that developed HDZero, and HDZero is a proprietary technology for wireless low latency digital video transmission. And it's this HDZero technology that we're going to be talking about in the rest of this video. Sharkbyte is a product line that was developed by Fatshark that incorporates this HDZero technology for its digital video transmission. So to avoid confusion, I'm going to be referring to the technology HDZero in the rest of this video. So let's start by summarizing how the HDZero FPV system converts an image that's incident on the camera into a digital wireless transmission that can be received by your goggles. So the start of the process is exactly the same as for all other FPV systems. An image lands upon a CMOS sensor, and those photons of light are converted into a raw digital representation of that image. That image is passed to an image signal processing chip, which attempts to improve the quality of the image as far as is possible. That image is then encoded into a digital video signal, which passes along wires between the camera and the VTX. That digital signal is received by the VTX, and here's where things differ slightly from the previous systems we've looked at. It undergoes a process called joint source and channel coding, where the digital image signal is directly encoded into a digital wireless transmission in one step. And that digital wireless transmission then is broadcast and received by your goggles, where the process happens in reverse to create an image that you then see on your goggle screen. So now that we've summarized the process, let's look at each step in turn and go into a little bit more detail, starting with what happens inside the FPV camera. Now, if you've seen my videos on analog or DJI digital FPV cameras, the process is much the same. In HDZero, the CMOS sensor inside the camera converts photons of light into electrical charge. This analog signal is sampled by an analog to digital converter, an ADC, to create a raw digital representation of each pixel in the image. This digital image is passed to a special chip, an image signal processing ASIC, or application specific integrated circuit, which performs processes such as sharpening, wide dynamic range, white balance, and other things, all to improve the image quality and try and turn that raw digital image into the best quality image that you can possibly create. This improved image is then sent to the VTX over a digital interface called MIPI-CSI. And this is the same interface that's used in the DJI digital FPV system as well. MIPI-CSI stands for Mobile Industry Processor Interface Camera Serial Interface, and it's really just an agreed standard for digital image transmission. The data rates for uncompressed digital video, which is what's produced by the HDZero FPV cameras, are huge. So looking at a 24-bit image, 720p at 60 frames a second, that's 1.32 gigabits per second of data. And to handle that, MIPI-CSI uses up to 4 parallel data lanes, and each one running at 1 gigabit per second. And you can see here how this is arranged. There's a clock lane with up to 4 data lanes, and each of those data lanes runs at 1 gigabit per second. You can see that each lane has 2 wires, and that's because it's a differential digital signal. And that means when the signal on one of those wires is high, the other is low, and vice versa. And by having those 2 wires, it makes the signal a lot more robust to noise and electrical interference, and therefore allows you to run higher data rates. So once that digital video has been sent over the MIPI interface from the camera to the VTX needs to encode it and then send it over radio frequencies so that it can be received by your goggles and converted back into video. And the way HDZero does this video encoding is completely different to typical digital video, and it's also completely different to the DJI FPV system as well. So in a traditional digital wireless video transmitter, the uncompressed HD video is first passed through an encoding step where it's compressed and encoded into a format like H.264 or MPEG or any of those other formats. Once that video has been compressed, that data is passed to what's called a baseband modulator, which splits that data up into packets that can be sent over a wireless link. Those packets are modulated onto RF carrier waves and then sent over the antenna. In the HDZero system, encoding and baseband modulation are done in one step using something called a joint source and channel encoder. So this takes the HD video in, encodes it, and converts it to packets of information that can be sent over a wireless link, all in one step. And those packets are then used to modulate RF frequencies and transmitted out over the antenna. Because HDZero has this single step for encoding and modulation, that helps reduce its latency compared to the DJI system, which has to do the encoding and modulation as two separate steps. Now, the precise method by which HDZero encodes and transmits its video is proprietary and confidential, but following some discussions with Carl, I think I understand enough to be able to explain to you roughly how it works. Now, each frame of video is split into chunks of several lines, and each chunk of several lines is encoded and transmitted separately. No data from previous frames is used in the encoding, and this differs from analog, which transmits one line at a time and uses no previous data. And it also differs from normal digital video and the DJI FPV system, which transmits one frame at a time and can use previous data from previous frames as part of the encoding process. And you can see how HDZero would slice up an image into stripes of several lines at a time. Each chunk of a few lines is compressed to reduce the data rate. And the exact method of this compression is proprietary, but we can guess that some typical image compression techniques may be being used. Things like intra-prediction, transform and quantization, and chroma subsampling, to name a few. Now, if you're interested to learn more about these different image compression techniques, then I have a video explaining how the DJI digital FPV system works, which will give you all that information, and I'll put a link to it down in the video description. Unlike the DJI system, HDZero encodes and transmits the image data at the same time as it's processing a chunk of a few lines of the image from left to right. This data is sent over an OFDM digital link with a variable data rate depending on the link quality, similar to the way the DJI system works. And you can see in this diagram that the encoding and transmission is all happening together as the system is processing this chunk of a few lines of the image. And this really helps to minimize the latency, because rather than having to wait for a whole frame to be encoded, the data is being transmitted immediately at the same time as the encoding is happening. Now, HDZero uses a 27 MHz wide channel split into 1,024 data lanes. And each of these lanes has a theoretical throughput of approximately 27,000 symbols per second. If the overhead on the link is similar to Wi-Fi, and there's no reason to think that it isn't, that gives approximately 22,000 symbols per second of useful data per lane. My understanding from what Carl told me is that the max channel data rate for HDZero is close to 100 megabits. And this suggests that they may be using 16 QAM modulation to be able to squeeze all that data into such a narrow channel. Now, all wireless links are susceptible to interference, whether they're analog or digital, and digital data is transmitted as packets over the wireless link. Each packet of data that's sent has a checksum to check that it has been received without errors. And unlike the DJI system, HDZero does not use retransmissions to recover data lost due to wireless interference. Instead, the checksum is used to identify a bad packet and discard the data, and then post-processing is used on the image to attempt to calculate what the lost data might have been and try and repair the image as best as possible. Because each lost data packet only affects a very small number of pixels, the image remains pretty flyable even with a very low signal-to-noise ratio, and that explains why you see the HDZero image gradually degrade, somewhat similar to the way analog video does. You're losing more and more packets, but the packets that are getting through are still allowing reconstruction of most of the image. But you can see that each lost packet only affects a small clump of pixels in one chunk of a few lines of one frame of the image. And what this means is that even if we're losing a lot of packets due to interference, we can still construct most of the image and we can still fly through the interference and see through the noise, similar to analog video. Because we're not doing any retransmissions, we can't recover any of that data. But there's some image processing going on because the system does know which packets have been damaged. So there's some image processing going on to try and reconstruct the image based on what data there is in those packets. I hope you enjoyed that deep dive into the technology behind the HDZero system. I've got quite a lot of follow-up content on this planned, including an interview with Carl, the owner of Divimath, and some latency testing using a high-speed camera so you can see exactly what's going on in the goggles for analog, DJI Digital and the HDZero systems. So make sure you're subscribed if you don't want to miss that. Thank you to all my Patreons, without whom none of these videos would be possible. If you would like to join them, I'll put a link to my Patreon down in the video description and you can join for the price of a coffee or a beer. That's all I have for you for today, so until next time, I wish you all very, very happy flying.